Yeah, thanks for the introduction, Aubrey. And I'm gonna go through a number of different topics, sort of a rapid fire here. But there's resources online you can use to follow up in more depth. So I've been doing AI R&D since 1980s. I think I wrote my first lines of AI code in '79 or something. I've been attempting to apply machine learning and reasoning to longevity data since 2001. It was really shortly after the Human Genome Project came out. I'm like, well, now we finally got the data. Now we finally got the data to do something. And it's been a long road with both AI in general and the application of AI to longevity. But obviously, times are now very, very interesting for both of these things, right? And I'm gonna use the first half of this talk to give a sort of overview of where we are in AI and where I think we're going in AI, and then the second half to talk about some of the specific efforts and application of AI to longevity that's happening in my corner of the AI world. So obviously, AI is real now. There's AI products out there that are used across different vertical markets. We don't yet have artificial general intelligence, a term I introduced in 2005 or so for machines that can take creative and imaginative and inferential leaps well beyond their training and programming. But we're clearly creeping toward AGI from narrow AI. We have more AGI-ish things out there now than we did even a few years ago, although not yet human-level AGI. And I'm one among many who believe that once we get human-level AGI, that human-level AGI will probably be fairly quick about taking the next steps and creating smarter AGI, smarter and smarter AGI, going on to what you could call superintelligence, right? So in a little more depth, where we are right now, I mean, we have very useful AI now. We have fun AI bots to chat with and make pictures. We also have a situation where a small number of tech companies control most of the AI on the planet, using it for the good of a small sector of the Earth's population rather than for the global good. I mean, we have the former director of the NSA just signed on to OpenAI's board. So we have clearly there's a centralization of power behind AI as AI gets to be more and more of an obvious, serious thing. The approaches I've been taking to AI are somewhat of an alternative to the mainstream in a few ways. I'm looking not just at LLMs and deep neural nets, but at a variety of different AI algorithms being integrated together in a common substrate. And I'll say a little bit about that in a few moments. I'm also looking at ways to ethically source the data used to train AIs as opposed to the more exploitative models characteristic of big tech companies, and looking at ways to run AI on more of a heterogeneous, decentralized infrastructure rather than centrally owned server farms. And I think it's also important to be applying AI to do beneficial, helpful things rather than just, say, selling people stuff they don't need, spying on people and killing people and so forth. And obviously using AI to help prolong human life is among the most beneficial of the many beneficial AI applications that we can look at. So I mean, we can look at the AI ecosystem as a sort of tech stack from chips up to server farms and software frameworks, AI algorithms and applications all coming together to the sort of software/biological global brain coding the surface of the planet. And if we can look at the currently standard AI approach as a certain tech stack involving deep neural nets, running in frameworks like Torch or TensorFlow, running on centralized server farms like AWS and NVIDIA GPUs, and a lot of things I've been working on could be looked at as an alternate tech stack, right? Where there's a whole bunch of hardware companies making hardware that's appropriate for a greater variety of AI algorithms than just matrix multiplication-based based systems that are more appropriate for logic and evolutionary systems, putting CPU and GPU together on the same cache RAM, making novel things like GSI's APU, Associative Processing Unit. And then we have software frameworks like SingularityNet and others I'll talk to in a moment that let you integrate together multiple AI services in a less centralized way, rather than just putting them all on one server farm. We have software frameworks like OpenCog that I'll talk about in a moment that bring deep learning together with reasoning and other sorts of advanced AI algorithmics. So we're looking at putting together sort of a whole alternative tech stack. So before digging into the details, let me make a brief comment on the higher level. I mean, I think what all these AI systems people are building are coming together to really is a new level of intelligence. I think it's an intelligent global brain integrating together many different software systems and human systems on the surface of the planet. I mean, this global brain at first is humans giving birth to their AI mind children, and then the next generation of AI mind children will be birthed by the AIs. But none of us can predict where all this is going. You can look at it as a sort of primordial soup for the emergence of superintelligence. And there's a bunch of talk about aligning AIs to human values and being able to sort of guarantee what's going to happen as AI gets smarter and smarter. I mean, I don't think we're going to guarantee what happens as AI gets smarter and smarter. I mean, I think we can guide the transition somewhat, and I think we can focus on building the right AI systems, teaching them and instructing them well, and having them doing beneficial things is a big part of it. So I think working on AI for human longevity has a number of purposes. I mean, the primary purpose is I don't want to die. I don't want anyone else to die, unless for some perverse reason they really want to die, right? I mean, prolonging life is a good thing. The other reason is raising up your AGI mind, doing good things like helping humans live a long time. I mean, this has a positive effect on the AGI mind itself, and can help the AGI mind to grow in a generally human beneficial way. So I've written a book with the Gabriel Axel called The Consciousness Explosion. You can download a free PDF, or you can order it in various forms on Amazon. You look at the consciousnessexplosion.ai, covering these sort of broader points. But let me talk a few minutes about AI algorithms and frameworks itself before plunging into biology. So LLMs and other deep neural networks are very cool. They're amazing systems. I mean, I use them in my own work in various ways pretty much every day. They have some serious limitations also that I think will hold them back from being the central part of an AGI system, although I think they can be an ingredient in AGI systems. They're not good at complex, non-obvious, multi-stage reasoning like you need to do to write an original science paper all by yourself. Their creativity is impressive, yet highly derivative. I mean, they're just recombining stuff that's fed in. Like if you trained an LLM music model on music up to the year 1900, it will never invent neoclassical metal or hip hop, right? I mean, it will recombine the stuff that's been fed into it. I'm attempting to work around these limitations with a framework called OpenCog, which brings together its neural nets, probabilistic logic reasoning, evolutionary learning, and other methods on a common infrastructure of a giant in-RAM dynamic self-modifying knowledge graph. And then there's a whole cognitive architecture called Primus that explains how putting these learning and reasoning algorithms together on this big knowledge graph can emulate the kinds of thinking that a human mind does. Again, you can look up OpenCog Hyper on the internet. I've given a bunch of talks on that. There's a lot of depth there, or you can you can come to the AGI 24 conference, which is in Seattle in August, and also available online. We'll have a day-long workshop on Hyperon, but also a whole bunch of others presenting their own creative ideas about how to build AGI. I mean, some of which are LLM related, some of which are often totally different directions. So I want to talk for a minute or two then on another part of the stack, which is software for coordinating different AI agents, different AI software running on different machines. So as an alternative to AWS, Kubernetes, sort of centralized software orchestration methods, in SingularityNet, we've been using the blockchain since 2017 to create a framework that allows you to run different AI agents on different machines owned by different people, controlled by different people, and have them coordinate together at large scale to cooperatively solve problems. And SingularityNet AI agent system does this. I mean, there's a bunch of complex pieces inside it that I won't try to explain right now, but we're now actually integrating that with two other decentralized AI networks, Fetch.ai and Ocean, in a sort of decentralized network of decentralized networks, building on a bunch of other tools like the Hypercycle ledgerless blockchain. For those of you who are into the financial side of cryptocurrency, we're actually putting together, we're merging our SingularityNet AGIX token with the Fetch and Ocean tokens into a combined ASI token, which will be, I think, launched on Binance on July 5th or something. So there's a lot of work going into the decentralized infrastructure. None of that tells you how to build AI. It's just like, once you know how to build AI, how do you roll it out on a whole big decentralized network of computers owned by everyone and no one, rather than having to be owned by one big company or government agency. So there's a lot to talk about there, but I want to get on to longevity biology. So looking at the applications and agents portion of the overall AI stack. So there's a lot of different applications being built using OpenCog tools and being built on this decentralized platform and this sort of alternative, more decentralized and open AI stack that I've been curating. For example, True AGI is a company we formed to use this sort of technology to supply the needs of enterprises and companies. But I want to get on to the meat of things here. And there's two different projects I want to highlight, which are using these AI systems I've been describing to address longevity in distinct but related ways. And the first is Reju.AI, aka Rejuve Network, which is basically bringing together a community of people who are interested in living a long time and who are interested in pooling their knowledge, insight, and pooling their data into a sort of decentralized data commons that can then be analyzed to give them insights and to help create insights leading to longevity therapies of various sorts. And the initial flagship product of Reju.AI is the Reju.AI app, which has been in beta testing for a while and should be pretty soon released onto the market. We're also talking to some folks in China about doing a Chinese version. So we have a little booth outside here that you've all walked past and perhaps stopped at already from Reju.AI. The CEO of Reju.AI, Jasmine Smith, is sitting up here in the second row. And the basic idea with the app is you can put in everyday information about your life and what you're doing. In the next versions, you'll be able to upload more genomic data, medical records, and so forth. And the original purpose here was I want more data to feed my AI, right? So and this data, it should be given consensually and in an ethical way by people who are saying, okay, I'm giving you this data about myself so that you can discover therapies that I and others can use, and if they make a lot of money, maybe I get some little compensation from it. But as well as that, along the way, we want the data that you put into the app to give you some value in terms of insights about your own life and your own longevity quest. There's a bunch of Bayesian models as well as OpenCog LLMs, so that there's a bunch of AI inside the Reju app, which is the most interesting part to me, but doesn't matter the details to the end user. I think we should have a brief video here walking through a bit of the Reju app, except I don't know how to play it using this clicker. No? Can one of you nice gentlemen back there click play on the video? Not that video, that's the wrong video. No, that video. Yeah. Really? Well, the app is not as black as that. There's actually other things in it. Yeah, there. All right. Some exciting techno music to wake us all up in the morning. All right. So the basic idea with the app is information ingestion, what exercise you do, what you're eating each day, and any medical issues you're having. But if you put this in day by day, the AI can build a model of you. And obviously, if you've put in clinical or genomic stuff, the AI can build a better and better model of you. And you own this model of yourself. Everything's stored with strong encryption. So I mean, the blockchain underpinnings is helpful there. You own the model of you. AI algorithms can then, in a confidential way, use this model of you to give you insights about yourself, but with your permission, the data about you can be put together with a bunch of other data on the back end on our AI algorithms running on the Singularity Net Decentralized AI network, and can then help learn things about how to make you and others live a long time. And I think one big use of this as it develops will be for sort of decentralized DIY clinical trials. Like if you have a couple hundred people who are trying the same longevity therapy, they should be able to report how it's going for themselves, and you've got the sort of data you got from a clinical trial without needing a pharma company involved. Not that what the pharma companies are doing is bad, but they're not doing enough. And to the extent that we can do things on the side of that, with people trying different therapies, keeping records of what they're doing, and using the data of this to fuel AI, I think this can be very, very valuable. And it ties together with the other company that I've been engaged with, which also has a booth out here, which is Reju.AI. And I think we had a talk from Kennedy Schall, the CEO of Reju.AI, yesterday, which I wasn't here for, but she's giving another talk on Sunday, digging into some of the details of what I'm just gonna hint at here. And Reju.AI is focused more on the therapeutics discovery side. So we're taking data from all over, taking data from online, taking data from various partners that we have, taking data from the members of Reju's network with their consent, and then compensating them for this, and also using some unique data from long-lived fruit flies that we're working on in partnership with Genetion. Take all this data and feed it into the OpenCog atom space. So this is this weighted, typed knowledge graph that we're building in OpenCog that puts neural net AI, logical reasoning AI, evolutionary learning AI, puts all these together in the same knowledge graph, and then does machine learning and reasoning, trying to make hypotheses about what's going on inside all this data. So when I first started thinking about how do you apply AI to biology in 2001, the first thing I conclude is, well, let's take all these data sets out there and suck them all into one massive, like, cross-linked knowledge graph, which adds knowledge across different organisms, different body systems, different types of data. Well, we still don't fucking have that, right? And there's really no good reason humanity doesn't have that, except nobody with enough resources has cared enough. But as AI gets more and more advanced, the amount of resources it takes to do this obviously becomes less and less, right? And now LLMs, well, I don't think they're that strong as an AGI approach, though they can be an ingredient of AGIs. They're actually quite strong at taking research papers and data sets and sucking out the knowledge into a knowledge graph, right? So we're doing a bunch of this in a joint effort between Reju.AI, Reju.Bio, and SingularityNet. So we're using LLMs to take the data out of medical reports, research papers, and structured data sets, suck them all into cross-linked nodes and links in the OpenCog bio space, which you can then use. You can use to give insights to the Reju.AI app. You can use for therapeutics discovery with Reju.Bio. And I mean, you can use them to meet a variety of other needs also. So we don't yet have this ready to launch, but we're already sucking in a bunch of interesting data on an experimental basis. And this is quite exciting because, I mean, in modern AI, you need the algorithms, you need the data, and you need the processing. SingularityNet and such let you decentralize the processing power, provision, OpenCog, together with deep neural nets, give some very powerful approaches on the AI algorithmic side. Data, awful lot of data is out there on the web anyway, so you can make a quite big, beautiful bioatom space of integrated open data, and then you can also have more proprietary atom spaces that you've built from data from various partners who don't want the data to be openly shared. So we've got a lot of data from all over. The Methuselah flies that have been experimentally evolved over more than 4 decades to live 5 times as long as the original control flies with which the evolution experiment was begun. These flies give a quite unique source of data to complement all the other kinds of data that we're plugging into our bioatom space integrated knowledge graph. And Kennedy will say a bit more about this on Sunday. I mean, this experiment was started by Michael Rose at University of California, Irvine, actually before Kennedy was born. And so these fly populations have been evolving for some time. They live a long time. They're stronger. They're smarter. They have sex more. They're all around superior Drosophila melanogaster strains. When I started working with these flies 10 years ago, already, and then the flies did not live as long as the current ones. Already we discovered some interesting therapies, and by experimenting with long-lived flies and Alzheimer's model flies in different strains, we discovered some nutraceuticals, some supplements, novel combinations of traditional Chinese herbs, which not only helped make Alzheimer's model flies live longer and not be poor demented little flies. I mean, they also were shown in a human trial to help roll back moderate Alzheimer's to mild Alzheimer's and sometimes cure mild Alzheimer's. So we already saw that by looking at the DNA data inside and RNA data inside these flies, you could discover things that would help not only flies but people. But now we have fruit flies that live much longer than we did 10 years ago when we did that prior work. Like those flies lived on average 2.5 times as long as control flies. Now we've got 5 times as long as control flies. Now we have much better tools to actually study the fly's biological makeup, and we also have better AI. So we've been looking at these long-lived flies and seeing what we do with this data combined with all the other data that we're feeding in, right? And so on the very simple level, you can see, so we've got 3 strains of flies. There's the B flies, which were the original controls, the O flies, which live a long time, but their evolution was paused around 10 years ago, and the SO, super O flies that live a really long time. They're still evolving, and they live around 5 times as long as the B fly controls. So if you look, there's a lot of differences, just a few highlights. The O flies have more differentially expressed genes in carbohydrate, amino acid, nucleotide, metabolic processing. The super O's, the super O's are more different from the O's than the O's are from the B's, which is interesting. So as the flies live longer and longer, like we're seeing more and more divergence of the very long-lived flies from the merely mildly long-lived flies. The super O's have more differences in respiration, ATP metabolism, and ion transport processes. Big differences between super O's and O's as compared to modest but significant differences between O's and B's. Comparing the super O's to the B's, very long-lived controls, significant differences in aerobic respiration and mitochondrial processing. Not as many differences as we thought in DNA replication and cell division. So there's just huge differences. There's differences across 2,000 of the 14,000 genes in the fly genome. So the issue isn't that there's not differences to study. The issue is that so many things are different. And the reality may just be it's a huge complex of differences spanning thousands of genes. That's just hard for our little minds to figure out and hard to boil into simple therapeutics. So then we try to pinpoint some more highly specific things, right? So along those lines, there's 4 transcription factor networks that we've identified that are particularly important in differentiating the super O flies, and this is work from a couple of folks in the audience, Mike Duncan, and then Axel Schumacher, the inventor of the epigenetic theory of aging, who have been looking at this and trying to understand why and how these transcription factor networks are acting so differently in the long-lived super O flies, and how will you cash that out in terms of either nutraceutical therapeutics or drug therapies or gene therapies. But there's a lot of ways. So, I mean, we can already see some combinations of nutraceuticals we could try on the flies, following up our previous work, see what life extension properties they have on the flies, and then try them out on people. So I think I want to wrap up with another brief video, just if you could play this one, guys, back there. Another brief video just showing some of the things we're doing in the AI lab with all this data. So this I think, this screen capture is looking at some human data on obesity, but it's the same process we use for analyzing the fly data. And it's a screen capture of using OpenCog's system to do logic AI-based hypothesis discovery based on biological data. So we're using OpenCog-defined inferences. The inferences are depicted as inference trees, and then you can inspect those inference trees and see what logical reasoning was going on. And here we were trying to understand what are the causal factors behind the impact of obesity on the shortening of lifespan. And there's a bunch of gene expression data sets regarding that. You can apply neural nets to that, but you don't tend to get an explanation you can easily understand. If you apply a logic engine to that, you get a sort of inference tree saying, well, we see why if this gene is upregulated, this gene is downregulated, this gene is mutated. We see what's the logical explanation via which this could cause you not to live as long. And what you see here, an LLM is used to generate a textual explanation of the logical inference tree. So you're feeding bioontologies, you're feeding experimental data into this knowledge graph. You're having logical reasoning done, and then you can use an LLM, not in this case to do the reasoning, but to explain what the logic engine came out with. I mean, obviously, I know that's hard to follow in a very short video. This is just, it's in-depth stuff, and I could give a whole talk stepping through one inference tree, but the point I wanted to make is, I mean, this is real stuff now, right? Like I've been playing with this stuff for a long time, and more we get the feeling we're not just playing anymore. Like we can integrate quite a lot of data sets now using LLMs for the data import, and logical reasoning engines are working better. We can develop new hypotheses. The beauty of the flies is you can test these hypotheses more quickly on fruit flies than on people, and then move on to testing them on people. So obviously we're not there yet. Like we haven't cured aging yet. But on the other hand, using different modern AI techniques and using this sort of alternative AI stack that we're developing in SingularityNet, OpenCog, and Reju ecosystem, I mean, we're definitely advancing much faster in the R&D connecting AI with longevity informatics than we have during the previous part of my career playing with this stuff, and it's been quite interesting. And I'd encourage everyone to follow up with Jasmine, Kennedy, Mike, Axel, and everyone else here from the Reju teams with any more in-depth questions. We have a couple booths out there and people eager to answer your follow-up questions.
Thanks so much, Ben.
Thank you, Aubrey.
Thank you. So go away anyway, because we might have some questions.
All right.
Anyone want? There we go. Jose.
Ben, excellent presentation, and you have been working now on aging for some time. Some people like Goertzel says that we don't really need to understand how aging happens to cure it. So what is your take on that? Because there are many competing theories about aging still. We don't have a clear definition or theory, but do you think AI can help us to solve it without understanding the final theory of aging?
If I have to give a single word answer, it would be yes, but I think it's going to be more nuanced. I mean, I think we don't need a complete understanding of aging to reach longevity escape velocity, right? And we might already be at longevity escape velocity, or if not, quite close, right? So I do think that trying to understand the dynamics and the causal processing underlying aging can be an important part of discovering therapeutics, right? So, but it may not be one silver bullet for curing aging. So, I mean, it might be that one helpful therapy is discovered purely by correlative methods without a model of what's happening, and another valuable therapy is discovered by causal analysis of what's happening inside. Like aging is not just one thing. So the answer to whether causal modeling is going to be important for curing aging doesn't have to be binary yes or no either. Unfortunately, biology, the answer is always really, really complicated, right?
Yeah, that is certainly true. A question at the back.
Yes, thank you for your insightful presentation, as always, and you articulated, with regard to large language models, both some of their possible beneficial uses as well as their limitations. I'd like to hear you address how we deal with some of the, let's say, reactionary panic that the arrival of large language models has brought about, because while you pointed out their limitations, a lot of people starting in late 2022 began to think, oh, large language models are going to imminently take over the world and create a Terminator scenario.
I think the wisest way to deal with this reactionary panic is just mostly ignore it and keep on building useful, helpful stuff, and that's pretty much what's happening. I mean, of course, it's worthwhile to talk to the media and reassure people that the apocalypse is probably not imminent. But I mean, the bottom line is AI tools, not just LLMs, but others, are delivering a lot of useful value to a lot of people. So I don't really think we're going to see too big of a backlash about these things that everyone wants to use and are just being helpful for everyone. So I'm not actually too worried about that, although it is providing a certain noise factor in the background. But it's a much deeper topic, and I organized a whole conference on beneficial general intelligence earlier this year. We'll have a sequel one next year. So I mean, it's worth paying some attention to, but in the big picture, all that will be a footnote on the path to AGI and superintelligence, I think.
So given that answer, Ben, here's a question for you from me, and I want a 5-word answer at most.
All right.
All right? Do you think that OpenAI has cracked RSA?
Probably not.
That'll do.
No. NSA might have, though. I don't think OpenAI has the right technology to do it.
Okay, that's a fine answer. Question at the back.
Thanks, Ben. My question is specifically related to Reju.AI. I waste so much time every morning putting variables into an Excel document, analyzing them myself. I'm wondering about integrations. A lot of these apps are limited by the number of integrations they have. I don't see Whoop, Freestyle Libre, things like this on it. Do you see future integrations, these specifically, coming in conjunction with the app?
I'm not sure I fully understood the question.
Me neither. Try again.
I'm wondering about specifically, will Whoop and Freestyle Libre be integrated with the app? I just can see Fitbit, I can see Garmin, I can see Google Fit.
I don't know. You got to ask Jasmine. So.
Okay.
Fine. All right, Ben. Thanks so much.
All right.